Okay, in our first video, or first part of the lecture on @counter, we wrote the constructor, which did two things. It completed the instantiation of our instance field, and then it filled that instance field, that matrix, with a random assortment of ats and dashes. Okay, that was the one thing we did. The other thing we did was write a toString method. Okay, and so you make a string, return a string, and the middle, fill it, initialize it. We're filling it with all the ats and dashes of our two-dimensional array. Now you got to have the new line character at the end of each row. So between the outside loop and the inside loop, you got to put the new line character. That's tough. Okay, you have to use @mat.length because you're not accessible to, you're outside the scope of rows and columns up there in the constructor. Again, that was a very common mistake in the early morning periods. And then over in the tester, I just made a @counter size 10 by 15 and displayed it, and you can see what one might look like. They're random, so each time you run it, it's going to look different. Okay, all we're left with doing now is our recursive method. Our current topic is recursion. We're about halfway through recursion, maybe a little more than halfway through. To write the method, I'm going to follow the directions here in the algorithm help section. Okay, this is great stuff for the AP exam. At least the inbounds check is, and the dot equals method call. This is a really good if to write in preparation for the AP exam. Recursion through matrices, as the Barron's Guide tells us, is not on the AP exam. But so many little pieces of this class are all over the AP exam. Math.random, matrices, nested loops, all this stuff. Okay, so it says make sure that our position RC is in bounds. Well, how could R and C be out of bounds? Well, if our row number is less than the lowest row number. Rows start at 0. So if we're less than 0, we're out of bounds. So we got to make sure that R is at least 0. Okay. And of course, if that makes sense to you, the same thing's true for C, our column number. C is at least 0. Okay, that means we're not out of bounds low. We're not at row -1, we're not at column -9, whatever. But you could be out of bounds going past the last row, the highest numbered row, or the highest numbered column, the highest index position of a row or column. Well, the last row of this matrix named @mat is @mat.length -1. You got it? The highest row number you can possibly have inside of R is @mat.length -1. Anything bigger, we're out of bounds. Column, very similar. The highest column number we can have is @mat of row R dot length -1. Can you put that in there? Okay, if you've got that in there, you satisfied most of what that algorithm help says. But it also says not just, well, it didn't just say if R and C are in bounds, it says and the current spot is an @ symbol. So if this spot we're at, RC, is an @ symbol, then the if is going to be true. You always do your out of bounds checks first. Okay, you don't put this check for at the beginning, because what if you're out of bounds? Runtime exception, out of bounds, right? You've seen that far too often in your little programming life already. So there's the if. Lots of good stuff in that line. So if that's true, do what? That's just the if part. I told you it was just 3 or 4 lines of code, but boy, it's 3 or 4 pretty tough lines of code. Okay. If that's true, mark your spot as vivited. What's that mean? Mark your spot as vivited. Mark position RC of @mat as vivited. Now, we're not going to put AS space VISITED in there, are we? But we want to mark it. So we know we've been there. We know our code is working, at least this part's working. So what do you want to do? You could put a big X in there, a capital X in there. That'd be fine. You could put a big capital V for vivited. Let's do that. Let's mark this spot as vivited by putting a capital V in there. And so amongst our dashes and ats, after we call this method, we'll see some V's. And then finally, bump up the current count by 1 along with 4 recursive calls up, down, left, and right. Okay, I'll stop right here and talk about this a little more in class and get back to the video in a few seconds.